Welcome to Watch This Space. I'm NASA Administrator Jim Bridenstine, and today we're going to be talking about a new program. In fact, a program that NASA is very proud of. We are on the brink of launching American astronauts on American rockets from American soil for the first time since 2011, the retirements of the space shuttles. And so this is an exciting time. We have two providers for this new capability. We call it Commercial Crew. The idea being that NASA is not purchasing, owning, and operating its own rockets this time. In fact, we're going to buy access to space in a way that we've never done it before. We helped two partners, namely Boeing and SpaceX, develop capability to fly our astronauts into space with the hopes that NASA could become one customer of many customers, driving down our cost of access to space and having multiple providers, and those providers competing on both innovation and cost. Again, giving NASA more opportunity to do more things than we've ever been able to do before. And here we are, about a year away from sending our first astronauts to the International Space Station on our Commercial Crew partners. So this is an exciting time for NASA. And we are here today with some very special guests. In fact, these are some of our first pilots on the Boeing Starliner, which is a spacecraft that NASA helped develop that ultimately will be taking our American astronauts to the International Space Station. So with us, we have Chris Ferguson, who is not only a NASA astronaut, but he's a shuttle commander by trade. And in fact, he flew the last space shuttle that we had fly, the Space Shuttle Atlantis, back in 2011. And of course, we also have Suni Williams, who has done a number of missions to the International Space Station. She's a Navy pilot by trade, as they are both Navy pilots by trade. And in fact, they are both from the test community. So we're very excited to have you both here. And I'll start with you, Chris. Tell me, you have been announced as one of the crews for our first flights of the Boeing Starliner Commercial Crew spacecraft. You were involved in the development of this capability. Tell me, what have you been doing since you've been announced as a crew member?
Well, my life has changed slightly. I've been involved, as you probably know, since 2012 in constructing this. Shortly after I left NASA, Boeing brought me on to help finish the design and take the Starliner all the way to fruition and ultimately into space. So, but in the last couple months, since I knew I was going to be a part of this mission, my trajectory has changed a little bit. I'm a lot more into training and what it's going to take to get Suni and the rest of the Boeing team up to speed on how the software works, how the crew interface works, how we're going to live and work in space. It's a brand new vehicle. The first time we've done this, it's the first time we've really brought a new human-rated spacecraft to launch from U.S. soil online in almost 35 years. So it's an exciting time for us, and it's great to be back into crew training again. I mean, there is nothing better than training with a group of people who are like-minded and love spaceflight.
So tell me this, each of you have an astronaut uniform on, yet yours says Boeing. It doesn't say NASA. Tell me about that. Why is that?
So this is going to be a first. As you had mentioned, when this is all complete and NASA purchases services to go back and forth to low Earth orbit, the partner companies that you mentioned, SpaceX and Boeing, will all own the intellectual property that it took to develop this capability with the idea of marketing it elsewhere. So if you had to extrapolate this could perhaps be the beginning of a space line. Boeing builds many airplanes that they supply to airlines. Now we look at a potential business where we build spacecraft to provide a transportation service to low Earth orbit for businesses, for perhaps other countries that are interested in a program of their own. For tourism is always an option, in addition, of course, to the prime NASA customer.
Awesome. And Suni, tell me about a day in the life of Suni since you've been selected as a commercial crew partner.
Yeah, it's been a little bit crazy, but fun. I have to say that. Anything you're doing in the space business is fun. Previously, there was 4 of us who were selected for the commercial crew cadre, NASA astronauts, and we divided our time between both companies, SpaceX and Boeing. And now, since the announcement, 2 of us have come over to the Boeing side and the other 2 to the SpaceX side. So we've got to focus our training and attention on this spacecraft. And not only this training, Chris is underestimating the other amount of things that we're doing. We're also doing a lot of testing. Sort of like he was mentioning, this is a new spacecraft, so there's still a lot of things to look at inside the cockpit and how people live in there and how actually we're going to operate it. That's the next step after the development. So a day in the life of might be, to get back to your question, original question,
sure.
is maybe going to the simulator and trying out some manual piloting techniques, which we might get a chance to try in here, or talking through the procedures and
So
looking at
you're
how...
telling me in a few minutes we might be able to jump in this thing and give it a whirl? I look forward to doing that.
Yes.
You're a pilot, so
All right.
you know what it's like. So some of that, or maybe it's going into the static simulator that we have in Building 9 and looking at how the cockpit is laid out, how the seats are fitted, how the hatch is going to open, where you're going to position some of your stuff, stuff you're going to take, or stuff that you might have to change out, like carbon dioxide removal. So there's a ton of things that we have to do and we get to do. Another thing we get to do sometimes is go down to Kennedy Space Center. You know, the launch pad is there, and so we work with the folks that are working on the launch pad and the crew access arm and the emergency escape system. So it's an abundance of a lot of fun things to do. So it's pretty crazy, but a lot of fun.
So you have both been involved in the development of the Starliner, is that correct? At some level. And how is it, I mean, obviously you guys are both experienced with space shuttle flights and of course Soyuz flights as well. How is this, let's just start with the space shuttle. How is this different than the space shuttle and why is it designed so differently? Chris, we'll start with you.
So it's a simpler mission. The space shuttle was 14 to 16 days in space. It was like camping, really. And it had all the, I'll say, the comforts of home. This is really sort of a point mission. So we'll launch and dock with the space station within about 24 hours. So the sort of the home creature comforts are really not a part of the mission. So we'll dock within 24 hours of launching. We'll stay docked to provide capability for the crew to come home quickly if they need to. And then after the crew's increment mission is over, we'll bring them back and be on the ground within about 6 hours. So we, like the space shuttle, do land on land. However, we don't do it on wheels. We actually have parachutes and we have airbags to cushion the final landing, and we'll land in one of 5 selected landing sites in the western United States.
Suni, do you have anything to add about how it's different than your space shuttle flights?
Well, Chris mentioned how it is different from shuttle, but it's actually very similar to Soyuz in its mission and what it's supposed to do. So while it's docked to the space station over that 6 months' time, it's also a lifeboat. So the vehicle needs to be capable to be in space for that long, whereas the shuttle was only a couple weeks. This is going to be 6 months on board the space station. In case there's any problems while the folks are living up there, they can jump into the spacecraft and make their way back to Earth. And that's a really needed capability for sustaining people living on the International Space Station. It's like the Soyuz in its mission. It's a lot different from the Soyuz on the inside of it. The Soyuz, you know, is a heritage vehicle from the 1960s, has a lot of upgrades in the number of years, but it still maintained that shape. This is a brand new spacecraft designed brand new with new technologies and new manufacturing techniques to put this and its rocket together. And so it's a big step in technology. So it's more capable, and it's going to be a little nicer to fly, I think.
So when these spacecraft are certified, the Starliner is fully certified, how many astronauts and or passengers would a Starliner be able to carry to the International Space Station?
So right now we can accommodate 5. NASA's requirement, what they've asked us for, is 4. So we can barter and trade on what you want to do with the 5th seat. There's opportunities out there for, like I said, tourism or perhaps business. If need be, we built it originally to accommodate 7, and with some minor modifications, we could carry up to 7. It really depends on the destination. Right now, we have one destination up there, the International Space Station, which is a vibrant and living place. We'd really like to see other destinations in low Earth orbit, however, perhaps commercial manufacturing facilities to give us other places to go.
Absolutely, and of course, that's a big piece of why we're doing commercial crew. We want to see, in general, low Earth orbit be commercialized in a way that enables NASA to use its resources, enables NASA to use taxpayer resources to do things in environments for which there is not yet a commercial capability.
Right.
So we want to use our assets to go to deep space, go to the moon, go to Mars, where there is no commercial capability. But in low Earth orbit, if we can get to a day where Boeing can take passengers and that can help offset the costs, and then not just passengers, but also industry. And there's things happening on the International Space Station right now that are amazing. And if we can transition to commercial operations to include the idea that we can use adult stem cells to create human organs that can then be used to extend people's lives. I mean, that's a capability right now under development that could be absolutely game-changing for the microgravity environment, which is only available in space. And if we can commercialize that, and so when we talk about taking passengers into space, we're talking about taking folks that are scientists, that are maybe bioengineers, people that can do things that are unique and never been done before, to commercialize low Earth orbit, and then we can use NASA's resources to do things that commercial isn't ready for yet, which is really an amazing capability. And so we're very excited about what Boeing is doing and what Starliner is, and of course what SpaceX is doing with the Dragon as well. Just so many opportunities. Suni, you tell me, how long you've spent a lot of time in space. How much time have you spent in space?
A little over 320 days.
A little over 320 days. So this time, when you go back, how long are you planning to stay?
Probably 6 months.
Another 6 months.
Yeah, 6 months, and I hope we get to fill the other 2 seats with some of our international partners.
Oh, that's
sort of like
great.
you're talking about, and fill out the complement to make us 7 people on the International Space Station like it was designed for.
That's amazing.
We'll get a lot of work done.
So when you think about your time that you've spent in space, which is an amazing amount of time, how do you think this time will be different?
Well, like you mentioned, right, the International Space Station is complete. And my last mission it was as well, but this will be an additional person to be up there, to be working and doing some of the science that we've been, that station is capable of. And I think we're going to be able to deliver a whole bunch more stuff, science back to Earth. So I think that's going to be different. And of course, the major part is the vehicle that's taken me up and taken me back is going to be different. It will be docked at a different docking port.
Okay.
The space station has 4 docking ports in the aft end for the Russian vehicles, and we'll have 2 docking ports in the forward end for manned vehicles, and then 2 docking ports for cargo vehicles also in the forward end. So it's a busy space station, and it's going to get more busy with all of these vehicles. So it's going to be exciting, an exciting time.
So, Suni, you have had the experience of landing in a capsule on land before, and now you're going to do it again. And Chris, this will be new to you because you've always landed on wheels, which of course was very, very nice. But in this particular case, you're going to you're going to land on land without wheels.
Don't be afraid.
Yeah,
it'll work.
Share with me what is the experience like, and what is the process?
Yeah, so I could talk to Soyuz. I can sort of talk to Starliner. Maybe I'll let Chris talk a little bit more about it. But it's a bunch of controlled explosions as you're coming back into Earth orbit and then landing. Of course, you have to slow down a little bit, so the vehicle will turn itself so it can slow down and start entering the atmosphere. After that, or before, depends on the vehicle, you're going to get rid of parts of the spacecraft because you want the descent module to be the key place that's carrying you and holding you and bringing you back safe. And so the explosions in the Soyuz go on above you and below you, and you can feel it, you can hear it, it's pretty dynamic. You're happy when it happens because that's what's supposed to happen. The next thing, we have a nice big window in this vehicle also. We had a couple windows in the Soyuz. You can see the plasma right next to your head in the Soyuz. When you're on the left seat, it's right here, and it's pretty shocking to see it's only a couple inches away from your head, but we have trust in these spacecraft. This one will be the same, and we'll probably be able to see it from in the big window here. And then as you slow down, then the parachute opens up. For Starliner, there's a couple other little explosions too to make sure that the parachute cover is off and then the parachute can come out. And you are in this capsule at the end of the parachute, and of course it's ripping out just like a normal parachute would, and that tends to make the vehicle move around quite a bit. So you're nice and tight in your seat as you are coming in. You're feeling gravity. You want to pull your straps pretty good because you're going to be bouncing around quite a bit just on the parachute. And then once it settles down, don't stick your tongue out between your teeth because you're going to be ready for that landing. And the landing for Starliner is going to be on some airbags. On the Russian vehicle, there's a couple different things that they did. The seat stroked, and then there were soft landing jets that fired right before landing. Here we'll have the airbags come open, and then we'll know we're pretty close to the ground. Get ready. Just sort of get in your seat and huddle down, get ready.
So when I watch
we'll be okay.
when I watch a Soyuz capsule return, that last burst, that last rocket fire right before it touches down. I've seen it start fires.
Oh yeah.
And of course, if you're not used to seeing it, it's pretty startling. You think something went wrong, but in fact, it's supposed to happen that way.
Right.
In this particular case, there's going to be airbags rather than a rocket burst. Is that right? So
Yep.
the idea of starting a fire goes down.
I hope so.
So if we see a fire now, something's gone wrong.
We always, all of our landing sites are dry lake beds, so there's very little to burn.
Okay.
But at the same time, you had mentioned airbags. What we do at about 3,000 feet off the ground is we jettison the heat shield that just protected us from the heat of reentry.
So hold on right there, because she mentioned the plasma. You were able to see the plasma. When you talk about plasma, you're talking about subatomic particles that have come off of that heat shield. Is that right? Which is ultimately what protects the astronauts inside. So that they call it an ablative heat shield. In other words, the heat shield is not, it's intended to not come apart, but it's intended to shed,
To burn off,
to
yeah.
burn off its skin, and then that skin ultimately protects you from heat and friction and ultimately crushing the capsule. Is that right?
Right, it's about 2,500 degrees, give or take a couple hundred degrees. But it is, you mentioned the plasma, it is, we have a vehicle that's traveling about 5 miles per second, and you literally slam into the atmosphere, and when you do that, you take those air molecules that were formerly things like nitrogen gas and oxygen, and you disassociate them, and you turn them into just, it's plasma gas. It's just sort of free atoms.
Yeah.
And they rapidly disassociate, and they create heat. That heat is carried away by the ablative heat shield, and then they reassociate back over the vehicle. It's really an amazing process.
Wow.
But you do have that thermal protection beneath you.
Yeah.
But once you get down below about 100,000 feet of altitude, you won't need it anymore. It's cool enough. And as I mentioned, we'll eventually jettison that heat shield to expose those airbags that will cushion our final landing.
So how do you, when you say jettison, is it burst off by rockets?
There's actually 6 explosive bolts. So Sunny had mentioned there's plenty of explosive
Explosion.
devices that occur on the way down.
Okay.
It's going to be a cacophony, and it's going to sound like a the 1812 overture, I'm sure, for a period of time there. But there are 6 bolts that hold both the service module, the bottom part that we need on orbit, to the crew module. We'll jettison that before we deorbit, and then finally there's 6 more bolts that will release the base heat shield as we get close to the ground.
Awesome. So the other day I had the opportunity to go out to Huntsville, and I was able to see the components for the Space Launch System, which of course is our deep space rocket. And I was fascinated, and of course both of you were involved in being test for the United States Navy. I was fascinated with how the technology for avionics ultimately compares to that of an aircraft. There's an inertial navigation system that's on board, and it's constantly measuring tiny little movements. And so your aircraft, in this case, your spacecraft or your rocket, always knows where it is: latitude, longitude, altitude, yaw, pitch, roll, trajectory, velocity. All of this data is being collected real time, and then your spacecraft or your rocket is comparing all of that data to where your rocket actually should be. So if there is a difference in where it is and where it should be, it then creates a solution to that difference and maneuvers the rocket nozzles to get the rocket headed the right direction, or the spacecraft headed the right direction. And seeing how it all relates to, these are the same type of things when you think about what an autopilot is on an airplane. It's all the same kind of tech. You've got flight control computers, there's redundancy built in. So share with me, and really for the audience, how has flying test in the Navy ultimately prepared you for this? I'm a Navy pilot by trade. I'm not a test pilot, but a Navy pilot by trade, and I was astonished at how similar the technology is. So share with us, your view on how you were prepared and trained, and how it relates.
So, I think the first thing is to design a good test. Make sure that the intent of the test accomplishes what you need. And what do new astronauts need in space? They need a vehicle that's safe, that holds the air, that gets it from point A to point B, that knows where it is all the time, that has a system of flight management and systems management computers that can help the pilot along the way. And we mentioned sort of the comparison between older and newer spacecraft. Newer spacecraft are designed to be completely autonomous. As a matter of fact, that is one of our requirements that we work to. So the astronaut is really a systems monitor. So it sort of has turned the test pilot role into more of a, I need to watch everything, make sure it's doing what it's supposed to do, and if I need to intervene, I can, but generally I don't anticipate doing so. So as I mentioned, within 24 hours, with very little pilot intervention, we expect to see our vehicle dock, and it can fly with a crew or without a crew. So test has changed quite a bit, but a lot of it's still the same. Is the vehicle safe? Does it sustain human life? Does it get me where I need to be? Does it give me the situational awareness I need so I know where I am and I don't inadvertently take over manually?
So in this particular case, we're gonna get in the spacecraft here in a few minutes, and we're gonna fly it. Are we gonna dock it?
You're going to dock it.
I'm gonna dock
You're
it.
going
Okay.
to dock it.
Now, if we were to dock in real life, would it be automated or would it be manually flown?
Yes, we could do both.
Okay.
The design is automation. But you mentioned about guidance, navigation, and control. Do I know exactly where I am? What I always think is a miraculous thing of spaceflight is the ability of our sensors to take vehicles that are traveling 5 miles per second relative to one another, and when they bring them together at docking, they're traveling relative to one another of about 2 inches per second.
Amazing.
And that is all through just a series of small orbital burns.
Yeah.
But we can bring it in for a manual approach, which is what you're going to get to try here shortly, or we can give it.
I'm sure I'll rock it.
We can give it to Hal and let Hal fly it. I'm sure you'll rock it as well.
I would imagine as you guys go through training, Sunny, while there is a lot of automation, you don't train for the automation. You train for something else.
Right, and part of that that whole getting the autopilot ready to work, not only just flying, but how the whole system works, other sensors it's turning on, other systems it's turning on when it needs to turn on for heating, cooling, air, carbon dioxide removal, all of that. We have to ask the right questions to make sure the autopilot does the right things. I think that's a big part of it. And NASA came in a little while after Boeing started designing the spacecraft, and our role as the cadre I was mentioning beforehand was to come in and start asking all those questions. So how does it do this? How does it do this and that? The things that we would expect a spacecraft to do. And some of these things in both companies are a little bit different than the way we've done them in the past. And that's good, because that means it's an advancement in technology. But we all train for also the backup plan. So when something doesn't work by the automation, how do you recognize that? Chris mentioned situational awareness, so make sure you have good situational awareness and know how to automatically take over to keep the crew and the vehicle safe.
That's amazing. Now, when we walked in here, we walked through an area where there were people sitting at computers, and you mentioned that this particular group of people they were by definition evil, I think is the word that you used. Share with me.
The bridge.
Tell me why that is. And I know you're just kidding, but what is that all about?
They are not evil. They are wonderful people who are dedicated to the success of every space flight. And astronauts may be the most visible part of the space program, but really, to coin a phrase, we're standing on the shoulders of a lot of people who really make this happen day in and day out. And not the least of which is the mission operations team, who actually plan the mission to make sure we have all the consumables to execute it as the way we intend to, the ones that train us to make sure that we know how to respond appropriately to the malfunctions that occur. And some of the veterans that you saw back there had been with us in the Space Shuttle Program. It's great to see them back for the phase 2 of what's human spaceflight going to look in the 2020s. And and one of them I'll even mention by name, Susan Crippen, has just been fantastic. She taught space shuttle pilots how to fly aborted missions in the space shuttle, something we hoped we never had to do.
Yeah.
And every time Susan walked into a room, and she's this diminutive, wonderful person, she made the most macho astronaut shudder because he knew he was in for a hard day.
Yeah.
And she's working as a part of our team today, and it's just great.
So what they do there in that room is they'll start the simulation for us, not only us, but also mission control. So it's a quiz sort of for us and them. And they'll put in malfunctions, like something broke on the one of the boxes, some of the computer, something broke, and we have to figure out how to handle that, how to continue the mission, whether or not we take it offline or try to put it back in the set. We work with mission control, and they analyze us and evaluate us and see how we do all together. And we'll do this a lot. And right now it's in the infancy, the growing process, as we're actually learning how all the software works. But once we figure that all out, those guys will be coming up with evil scenarios to stick in there that will make it very hard. But those are those taxing scenarios that we all need to do so we understand the vehicle inside and out.
And to be prepared.
And to be prepared, yep.
A good friend of mine is another naval aviator, John Harrington, first Native American in space, and of course from the great state of Oklahoma, which
Yes.
is my home. So I used to run the Tulsa Air and Space Museum, and he was very helpful to me in those days. And one day he was talking to me about his shuttle flight, and he said, you know, it was amazing because they had done all of this training for all of this time getting ready for the shuttle flight. And then on the day of launch, nothing went wrong. And he said it was a little nerve-wracking because you expect something's, you got to be doing something, you got to be busy. And he said nothing went wrong, which means that obviously you guys are well prepared. You've got a great crew. Of course, we've got amazing engineers and scientists that are making it all come together. And we're just so proud of you. We're so grateful for your willing to step up in this new capacity after both of you and all of the others have already done. And of course, this represents a great capability for the United States. A lot of people don't realize launch is now an export for the United States. It was only about 5 years ago, we didn't have really any launch capability. And now, not only do we have domestic launch capability, we have launch capabilities that we export to the rest of the world, which you know, it offsets the trade balance for our country. And a lot of it is because of our development with commercial resupply to the International Space Station and getting those other customers on board for those specific rockets and spacecraft. And now we're going to go to the next step, and it's not just resupply, but it's commercial crew. And the two of you and so many others are involved in making this really an amazing capability for our country. And it's not just about science and technology, it's about the American economy and exports and making available space to more people than ever before. And that really is going to be transformative for all of humankind, not just for the United States, but for everybody. So we're so grateful for you guys for being here. And I'm looking forward to getting in this simulator and seeing what it is, and ultimately seeing if I can dock with the International Space Station.
You won't have a problem.
No
You
doubts.
ready to jump in?
Ready to rock it.
Ready.
All right, let's do it.
4.8, so you're about halfway there. You see these things like dice in the picture?
Yeah.
They're actually our key targets that our cameras are looking at. And you can actually see there's a green line that's surrounding one of the marks on the dice.
Oh, it's so I feel like I'm afraid that.
Oh, you're doing good.
You're doing good.
Yeah.
Should I slow down?
Nope. Closure looks good.
You don't want to go too slow either coming in because you want to make sure that
You contact.
you contact.
But you're good at
You're good.
0.44, about 3.2 meters.
Looking good.
Oh. Well, it's really getting hairy.
Again, that's just your circle getting
Getting
smaller. though.
yeah.
It's not heading the right way.
Give it a little time.
2.6, yeah, just let it react.
Yeah.
Here it comes coming back. Closure still looks good. There you go.
Nice.
That's a good input. Get about 2 meters now, look real good.
Ah.
You're good, you're good,
You're
you're
fine.
good.
Remember, you have that big magenta circle. Really close, about 1 meter now. I think you got this one down. 1.2 meters. Really good. Nav looks good. About 1/2 meter.
Nice.
I don't want it to run away on me.
0.6 looking good. 0.5. Closure looks good. 0.3. 0.2. 0.1. 0.1. Contact.
Capture. Nice.
You're in.
I should have been an astronaut. Well, thank you so much. A lot of fun. A lot of fun.